ready with the pooled weighted average?
minus
Not the pool.
P2.
Yeah, that's right. So then you plug that into this.
S, because
Yes.
it's a pool,
Well, it's the same thing, right?
pool
You just have
population.
to decide on
Yeah,
what.
you do the
Yeah, okay, it's the same thing. The thing is, the hypothesis is that that true population proportion is the same as that true population.
right, 'cause you don't have
But this,
the
we can understand.
standard
I thought it was like
deviation.
P5. We were looking at this.
I do mine. You do it. We got the right calculator.
Oh, yeah.
Alright, good.
That's the big deal. You know, I was telling you, it takes for 2 and 3. I did the number the other day. Yes, they don't, you said not the rounded, but I know you said it was rounded. I got a lot of She said she's probably looking at it, she did it, but I told her, I should bring you in. I said, you know.
Alright, see that? This is the same. Yeah, it's the same thing. Yeah, the point is that population of 1 to population 2 are supposedly the same. So you should find
So now that whatever number I get there.
I just personally think that I'm gonna give her a kind of advice and send
It's that number, and you see a pie sign with
Oh,
1
okay.
or 2.
So this entire equation is power.
Yes.
Times 1 and 2.
This entire equation, right here, just
This
this
one
one,
is right here.
this one,
Which is
equals pi 1, pi 2, pi 1 and pi 2.
it equals both pi 1 and pi 2. So I am doing this point 0, here, here. That don't happen. But the equation is this. So I'm only doing this here and then entering that into the equation. I don't know. I'm lost.
Yeah.
Okay, so I'll just start here. I'll go there.
Okay, you got it. So plug that into this one and tell them that you're
No
gonna.
different.
And then I'll calculate that. What's my next step?
Then you go
Excuse me?
to the z-set. Yeah, then that's the z-set.
Are you doing 0.65 times 2.6?
That'll be my.
You are, right?
Yeah.
We did
And
do
then
that.
I'll have
We did make it. Yeah.
Yeah.
But when you get home, as long as you does something like that.
Yep. So it's 5%.
So you already like, what did you do?
What's that?
40. Keep that number. That's your standard deviation or the standard error.
Alright, should we do this together?
Calculate the standard
We
error.
ready?
That's
All right, fantastic. So this is an interesting one. We'll take as much time as we need to understand the numbers, because I don't want you to be confused by the numbers. We want to get the numbers and then think about the interpretation. So in this example, we're seeing a difference in the knowledge of two populations. So we've got home buyers. Some home buyers are college educated, other home buyers are high school educated. Now these college-educated home buyers were able to know a little bit more about how a mortgage worked. The question in this example is, did you know that a 30-year mortgage does not require a 30-year commitment? So if you take out a 30-year mortgage, did you know that doesn't necessarily mean you need to pay for 30 years? You can actually pay it off earlier. Did you know that? Raise your hand if you knew that.
Yeah.
All right, everybody pretends you knew that. I'm sure you all knew that, because you're college educated. At 65%. So 65% of college educated people knew the answer to that. Now, smaller percentage of high school educated people knew that. So this potentially, I know it seems like a small difference, 5%, but potentially could be a big difference if we're talking about millions of mortgages, and we're talking about some of those mortgages or mortgage owners, buyers, default on their mortgage because they don't have the right knowledge. And then we have a housing crisis, right? Some of this information, some of this lack of knowledge could be attributed, or that could be used to attribute to the recession in 2008. So if you're working for Fannie Mae, you may say, gosh, there's a big difference between these two population proportions, college educated and high school educated. So maybe we need to do something about that. Maybe we need to start an education program to teach people the information they need, and we won't have another housing crisis. You with me so far? All right, so let's assume a null hypothesis that there is no difference between these two populations, proportion of college and proportion of high school. Now maybe what we're trying to prove is that there is in fact a difference. So we kind of want to be able to reject this and say that we have overwhelming evidence this is not true, and say, you know what, there really is a difference in the knowledge of people who have college education versus housing education in terms of their knowledge of mortgages. And if we can prove that, then we might need to spend millions of dollars on an education campaign to try to make a difference. Okay, so we'll assume that there's no difference. We'll see if we have overwhelming evidence that there is a difference at the 5% significance level. So we go out and we get some sample data. We find that the college-educated adults are able to successfully answer this question at 65% versus high school at 5%. So based on our sample data, there is a difference. Right? There's a difference of 5%. Like I said, this may seem like a small number, but millions of people, it could make a difference in how the economy interacts and how things work with the housing market. All right, but the key question is that 5%, is that a big difference or a little difference? Well, it depends on the size of the standard deviation of the sampling distribution and sample proportion difference. So let's calculate the size of that standard error. You ready to do that? That's our next step. Let's calculate the size of the standard error. Now, I explained this sort of complicated procedure we use. Seems like a complicated procedure, seems like a pain, you have to memorize it now, but it actually helps us get a more exact answer. So if our null hypothesis is that in reality there is no difference between college and high school in the true population proportion, we can use just one number to estimate our standard error. So let's pool our sample data and find what our average proportion was in our sample, and let's use that number to calculate our standard error. So what do we get when we take a weighted average pooled proportion for our sample?
0.62.
0.62? 0.62 and some change, right?
Yeah.
Alright, so keep this in your calculator, store it. But for right now, just to make it simple, I'll calculate the standard error. So it's 0.62 times 0.38 divided by sample size 236 plus, we use that same pooled number, 0.62 times 0.38 divided by that sample size, 259, square root that whole mess. Are you with me there? Yes.
Real quick,
Yeah.
where'd you get the 0.38?
1 minus 0.62.
Okay.
That's the formula.
Oh, that's right. Thank you.
Okay, so we're estimating the standard error for this proportion difference. And if our null hypothesis is that there is no difference in true population proportions, then we can use one number to estimate that standard error. And that is our pooled weighted average proportion. Okay, what does that come out to?
0.04368.
4.68. Okay, very good. So about 4.4%. All right. So we're going to use that to calculate our z-stat in a minute. Before we do that, let's set up our critical values. So my null hypothesis is that there is zero difference between proportion of college-educated adults and proportion of high school-educated adults. There are two ways to disprove that with a really low difference or really high difference. My significance level is 5%, so I want the 5% least likely of outcomes. Since it's a two-tailed test, that's going to be split in half. 2.5% is going to be down here, and 2.5% is going to be up here. Combined, these are the 5% least likely outcomes. And if one of those outcomes actually happens, I'm going to consider that overwhelming evidence. So now, I need the z-value that separates the bottom 2.5% and the upper 2.5%. This is my rejection region, and it's 2.5% of the outcomes. Same up here is my rejection region upper, 2.5% of the outcomes. So what is the z-value that separates the bottom 2.5% from all the rest?
1.96 minus.
Equals negative 1.96. What's the z-value that separates the upper 2.5% from all? 1.96. Alright. So anything greater than 1.96, reject. Anything less than negative 1.96, reject. All I need now is a z-stat, right? Okay, so let's get a z-stat. Let's do it here. Z-stat equals, alright, so our proportion difference, 0.65 minus 0.60, that's 5%. That's the difference we find. And what did the null hypothesis say the difference was? 0. Alright, so the difference between what I find and what you say in the null hypothesis. And I'm going to divide by the standard error. 0.04368. Well, what does that come out to? 5% divided by 0.04368? 1.14. Very good. Alright, so I'm going to plot that on my sampling distribution sample proportion difference. I see that as z-stat equals 1.14. What is my decision?
Failed to reject.
Failed to reject. Yes, so that is not an unusual outcome if the null hypothesis is true. Alright, so we'll pause for a minute. We'll chew on this for a minute. Because the numbers on this one are a little complicated. We don't want to get stuck there. We want to be able to interpret it. So what did we do here? We said our null hypothesis is that there's no difference between college-educated adults and high school-educated adults in terms of the knowledge on this issue. And we didn't think that was true. We thought we were going to have overwhelming evidence to reject that and then spend millions of dollars on an advertising campaign through Fannie Mae. Because we were looking for overwhelming evidence. To the contrary. So we calculated, we found some sample data of our own. We find a sample difference of 5%. Alright, so our difference of 5%, we want to know how unlikely that would have been. And we found actually it wasn't that unlikely, as a matter of fact. what is the p-value for this z stacked?
38729.
How much?
Oh, never mind.
.2542.
That sounds right. Or 25%. So there's 25% chance of this sample difference if in reality there's no difference at all. Because in our sample we just happen to find a little bit of difference. Very high likelihood of that. Okay. So now suppose I want to use this sample data. I say there's a difference, on my sample data, 5%. And I think we should spend millions of dollars on this advertising campaign to increase the knowledge level of people who only have a high school education about mortgages. Do you see any flaws in that argument? Why would you disagree with my argument? That we should spend millions of dollars educating?
I would disagree,
Why?
because it's proven that the educational level doesn't have an impact on
Yeah,
the
yeah.
knowledge base that they already have
It
about mortgage.
yes, yeah, I think you're absolutely saying the right things. So the fact is, I can't prove that there is a difference at all in the whole population. So I may just be wasting my breath, I guess, with this. It's kind of a complicated scenario. You might say that it's doing some good, but in reality, there could be no difference between these two population proportions. It might not matter at all. Any questions on that?
I just have a question on
Yeah.
the p-value.
Yes.
I think it's 20.2542.
All right, so you look for 1.14 on your z table, and what is the area under the curve?
0.8729.
So based on what you just said, I might say the p-value is 13%?
But it's two tails, so we have to times it by 2.
Yes.
Oh, okay, that's what it is.
Yes.
Alright.
Very good. All right, so the chances of an outcome at least that extreme. Okay, so let's, failing to reject, failing to reject.
So if you subtract it from 1.
Yes,
But the standard deviation, should we use the S for the standard deviation? Because we're estimating.
okay, so the S is just for means, because remember with proportions, there's no such thing as a population standard deviation. It's like you either know the answer or you don't. There's not an extreme person who really knows the answer or doesn't know the answer. So the underlying proportion, notice we don't have any standard deviations here. So once we get to the sampling distribution, then we have a standard deviation. And what is the standard deviation here? Well, it depends on what the true population proportion is. And if the true population proportions are exactly the same, then we can just use one number to estimate what that is. Thank you for nodding. Makes me feel good.
So if your confidence level was not 5% and it was more in,
It was higher?
your significance level, I mean,
Yeah.
was more like if your rejection region was closer to 0, then you would like, let's say it was 1 more in, you know what I mean? Like,
But talk to me in terms of significance level.
okay, so let's say your
Because-
significance level was 10%,
Yeah.
and so now your both sides are 5%.
Yeah.
Then if we got the 1.14, we would reject because it would be within.
Yeah, you're on the right track, but we would have to go further than that. Like how high would
So you're saying
we?
that because we chose the 5% significance level, anything within that, anything from the 0 to the rejection area region is valid. Is not, you're not rejecting if it's within that region.
Okay, so my question to you is how high of a significance level do we have to go before we would reject this null hypothesis? If we go to 10, do we reject?
Probably 13.
We would have to go all the way to 26 before we would reject. We would have to go further in.
So anything that falls within, even though you're saying, even though the equation says equal to 0. You know, I'm throwing you off, right? Cause it's equal, it's not like, it's like greater than or less than, like it's a range, so it could fall anywhere in there. If it's not exactly 0 is my question. Like, if what we got is not exactly 0, then it should reject. No.
But no, you're saying like it's right here we should reject? It doesn't have, the sample is.
I'm saying like that's far off, the 1.1 more, it's like closer to the rejection area than,
Oh, okay.
if we're saying
Yeah.
they're equal to 0.
Yeah,
You know what I
yeah, yeah,
mean?
good,
So
good.
that's my,
Yeah, so Kelsey's saying, alright, so this sample data is closer to not equal than it is to equal, right? So that's what she's saying. Are you with us?
so I get
So-
it that we're setting our confidence, our significance level to be 5%, so okay, you can't say that. But
Yeah, so why don't we just
it's
reject,
far off
because
to
it's
say
like,
that they're right.
because it's close, yeah, because it's closer. Yeah, so we have to determine our standard of proof. You know, are you gonna put someone in jail just because there's a 10% chance they're guilty? No, there has to be like a 99% chance that they're guilty before you put them in jail.
Okay.
So same sort of process. All right, good. Let's take a break. Let's come back at 8:15 and we'll finish up with the last little section. I will see you then.
We going to get some more cookies.
Yes, more cookies. Are the cookies gone now?
No, no, they're probably still there.
The cookies are probably still there, but
What cookies?
Should've brought them, sorry.
Come on.
Find the open
1260.
one, I don't know where it is.
1260.
Okay, huh?
1260.
Oh, that was where we did
Yeah,
turtle.
yeah.
Oh, we did?
1260.
I don't mind if I do.
They may still be there, like,
Some cookies back.
Who's in there?
I don't know, a couple of them.
John?
Oh,
The
he's
beat the
there?
purple,
Oh, that's
the
good.
beat
Say
the purple,
hi.
so you go to the gym.
For the cookies.
You can't go that way, right?
Start doing it. Reset the number, look up the whole page. But you can see that as you move up, like, your page gets longer and longer and longer. There's the p-value.
Hi, Ezekiel. How's it going? Do you understand this? I'm trying to comprehend. My mind is not computation. It's more so, I need to read something. Now I understand. No more digital books? No, it's about, how do we use this in real life? I get it.
And it's,
How is this relevant? In real world.
you get an understanding of it as you do all the questions that he outlined,
Yeah.
the more you do it, then you like,
The more you
yeah.
get it.
Right. I do the same thing.
And it's good that the question is based on real life situations, so you get a picture of it.
You know what it is that I think we're covering an entire chapter,
Yeah,
all within like 30 minutes.
3 hours, well, 3 hours,
But basically, right, one type
For
And
section.
different problems.
For section of the chapter,
Right,
yeah.
and
The
then the,
different types of problems that the chapter shows you.
personally, like, you know, as I go through school, with like, math is all about practices. And, you know, doing the homework, if you don't wanna do the homework, you're not gonna grab it as much. So all the questions he outlines does help you, you know, grab the information. If you do them,
No, we do the stuff that's online. I don't do that.
oh, you mean the quiz?
I do the quizzes in the Excel.
Oh, I recommend doing the question that he outlines in the syllabus.
Really?
Those does help, yeah.
Yeah. That's what we're missing. It's the missing link.
Yeah, it's time consuming, but you know, it does help.
Ezekiel, you have to? Oh, but you also transferred in from his other class. Were you at the same?
Wanna go?
You know what, the only reason I'm going is because the group. Like we have siblings.
Oh, so you, I don't know. In management already, so I wanna continue that. It seems like school wanted to venture out, maybe thinking about accounting, but.
I'll be good. Catch up. I have to catch up to one of my online classes. I'm tired.
I'm not interested in the finance part, so that's not where I'm heading. But I'm already in management. That's where I'm heading, but I'm thinking about dabbling into accounting.
After this week? Have you done, started on your anniversary?
I'm not even ready. You done with it? I thought like, it's gonna take me 3 years. Everybody's gonna take one job that they, one course a year. So at least I could take 3,000 dollars.
So I'm doing 4.
3 times 3 is 9,000.
I looked at them.
Because full-time job and I'm volunteering, that's why I don't even, I'm interested in the project, but I don't think I have
Victor's class is
10 hours a week.
Oh, yeah.
You took your last semester?
I dropped it.
She dropped it.
I dropped it last in the winter. Yeah, I was,
My kids, it's
now I'm
not
gonna do
taking
it
much
in the
time.
spring.
You gonna take him?
Oh,
They're
no,
young, so-
I got somebody else, I'm gonna be in Manhattan. I'm not dealing with her.
Those kids on Saturday.
I hate. But it was like, he said it was like four group projects, right?
Everything is group except for the.
Except for the,
Well, it's 4
Because
cases.
4
cases.
there's a,
The research and the final.
And then the final.
presentation.
and that all had to be done as a group.
So you with the same group the whole time?
Nothing.
So if somebody, and then the thing is like, you don't get to pick the group,
Right.
the signs of where.
Mhm.
Your grade is determined
Oh,
based
yeah?
upon what somebody else does. Not everybody takes it seriously.
And not a lot of people know how to work in groups, so it's like
3/4 of the way finished.
time management.
Everybody's schedule is different. You can't do it, you can't. But
Everybody be like,
Yeah.
oh, I work.
Okay, well, everybody else works too.
Yeah, it was a little bit too much. I'm kinda glad I did drop it, because then the same time that class started, my grandmother had went in the hospital, so I would have been going crazy,
Timing of it. Right.
so, yeah.
So
But-
what other, like I use Google Scholar sometimes. What sources do you use to get answers? For this case, I don't even know, like, cause for the other cases,
Some
like,
other
they would
cases.
just like Google and I got like some information. For this one, I was trying to do it last night, you know. That's what I realized I was reading through the case, I'm not finished, I think I have like 2 or 3 more pages.
And y'all taking 3 classes?
She is, I'm wanting to. But it's kind of, it's interesting because this class and my other class, my analytic class, they're kind of like parallel in terms of what we're learning in. So that class is a lot easier because it's kind of like the same thing, you're going through population,
Right.
standard deviation. So that's not so bad. It's this class right here. This whole group thing is.
Yeah.
In my group.
How many is in your group?
It's five, right? Five.
Wow.
But out of the five, there's like three of us that are strong, and then the other two is like,
Oh.
and it's bad because it's like, we have to pick up the slack, because we all, it's, you know, it's a new grade, so when we submit something.
Yeah.
And what is he kind of that thing that he said, like you can grade your other group of people?
I don't know.
I remember him mentioning it.
No, he did
And it's
mention
in
it.
the syllabus, but
Yeah.
he hasn't said anything else about that. I thought it was gonna be a grade for each case.
And what is this research part about? Oh, yeah, we have it assigned.
Yeah, he assigned each group a different one.
I didn't even realize he assigned it. All right, so that's fine.
I did that. Can't get over it. What night was that? Tuesday, Tuesday night, shower, finished early. Sat down to read it. Oh, Wednesday night? No, that was Monday and Tuesday night.
Yeah, like I have to read them like 3 times, so like I read through it last night. It's actually not as long as the other books.
It's not because the last 2 pages are scribes.
Right.
And then it's not the entire page, you have all these footnotes.
So it's not that bad.
Long, yes.
I mean, this is all about the economic, and then like another part, like the IT and industrial.
And then it's talked about the pros and cons
Yeah.
of doing that, what about it?
And they have a 5-year, 5-year plan.
I'm gonna throw the book in a minute. Yeah. Yeah.
Question or the quiz or something related to
For your conference.
we always use it.
I'm putting it in right. Is my, is my council a decimal?
If that's all together, right?
Yeah.
I'm about to tell you. So.
You sent me?
Right, that's on there, right?
For some reason,
That should be it first. See that first? And then I'm gonna say these.
And on the group stuff. And you search there. I didn't do it yet.
He's so funny. I can't. Like him, I would go to Applebee's.
Yeah. Because that's what I did for the
He's the one that we just like take out.
I entered the name first.
Yeah. Oh, so we only get it.
I got librarians in some other school.
You got it? Yeah, so the diamond.
Oh, did you do it well?
Yes.
Thank you.
I can't.
I didn't do it.
Really, you really doubt it? You really
I was
doubt it?
here
But you have to put everything right. Wait, right, you do it again. It's like,
So,
Yeah, it ain't working out.
that divorces that.
Like the information.
Come on, you have to. You see?
That drives me crazy.
Yeah.
I know, I don't think.
I think he's the one that leads them.
That's it, yeah. That's the whole problem.
Yeah.
No, that was it. That was chapter 8. I had the wrong.
He's
back
fine.
then.
You can tell he's fine.
The wrong one.
No.
It was hot.
Oh, yeah?
I've heard that. I hear her. I'm on cheat. Yeah, the one in the back. I hear you. Yes. But the day about it is by my sister, she'll have the kids in jail. She travel everywhere. I be mad too. I be jealous. I be like, ooh, that's not fair. Virginia, I just got to get on the thing.
Take the injection.
Nah, he can't do that.
Take me.
He gotta pay for that. He ain't got no other choice. That time and quality, he earned that, dealing with them. Oh, excuse me. I forgot. I'm sorry. Yes, you do. My kids. Shut up. Oh, no. I'm just gonna shut up.
Yeah, you have to.
All right, should we start? All right, so the last little piece, differences in means. So, you say the income, average income in town A is the exact same as the average income in town B. And I look at you and I'm like, well, I really don't think so. Let's do a hypothesis test. So if you tell me they're the same, median income in town 1, mean income in town 2, if you subtract them, you get 0. Again, this is just a fancy way of saying these two are the same. Mean 1 is equal to mean 2. Average income in town 1, average income in town 2. Alternative would be they're not equal. Suppose you want to get crazy and say, you know, not only, I know that there, I in fact think that, town 1 is bigger than town 2. The income in that place in New Jersey is bigger than the income in this place in New York. So if I subtract this one from this one, I'm going to get a number greater than 0. So mean 1 minus mean 2 is greater than 0. It's just a fancy way of saying mean 1 is bigger. I could do the opposite. Switch it around. Critical values, p-values, all that stuff is the exact same. You all are pros at hypothesis testing now. You'll use that same procedure. These numbers, these zeros, in this case we're saying that there's 0 difference between these two. We'll use those for all of our examples, but you could make different examples if you wanted to. You could say the difference of income between town 1 and town 2 is exactly 7,000. I could say, well, you're that friend who every time you say something I think it's wrong, so I'm going to say that it's not equal to 7,000. And I'm going to have 2 ways to prove you wrong. Much less than 7,000 or much more than 7,000. Okay, so I make a statement that the average income in town 1 is the same as the average income in town 2. You're skeptical of that. So you go out and get some data. Income in town 1, income in town 2. Alright, you find that in your sample data they're not quite the same. But that's just a sample. Of course you're going to be a little bit different in your sample than, you know, if you test the whole population. Do you have a tool to quantify how likely your sample outcome would be?
Yes.
Yes, what is that tool?
The sampling distribution of the sample mean difference.
Fantastic. Sampling distribution of the sample mean difference. Alright, if what I say is true, then this is the mean of this frequency distribution. Your sample mean difference is going to fall somewhere on this. So you want to see how far away your sample is from what I say is true. More importantly, you want to know how many standard errors of difference that is. So you need to calculate standard error. Remember this formula from confidence intervals? We just calculate standard error this way. Once we make those calculations, we say, all right, in my testing I found a difference in income of $7,000. You told me that there was 0 difference. All right, so my sample is off by 7 compared to what you say. And now I want to know how many standard deviations of difference that is. And that's going to be my z-stat. Now, since in the real world we're not going to be given population standard deviations in town 1 versus town 2, we're going to calculate them based on our sample standard deviations. And since technically we do not know the population standard deviation, we could use the t-distribution to be safe. But if you remember, when we get to mean differences, statisticians say, don't worry about it, just use the z-distribution. Because there's so many moving parts, they're going to balance out. So mean differences, as long as you have samples of size 30 in both populations, feel free to use the z-distribution. And then you'll substitute in whatever the sample standard deviation is if that's all you have. And you'll calculate your sample standard, your z-stat with that. Make sense? Alright, let's just dive in and do the problem. See how it feels. Page 362, number 24.
bless you.
Thank you.
I have to check my math.
Yep.
It's birth certificate.
Oh, good thing.
Wow.
Wow. No, it's not gonna take it credit. And you know, they keep doing it, even everything open for the blackboard and stuff too. They keep doing it, yeah,
Oh, they leave the blackboard on?
everything, you can,
You can fit in and mess with the
just mess
quizzes.
up everything, and everything gonna do nothing. Very tired.
Alright, should we do it? Another couple minutes? You tell me. Couple of minutes.
I'm in the, I got it. I got it.
Really, really, yes.
Yeah.
So now when this one is one tail,
Yep, yep. One tail.
so how do we know if it's one?
Okay. Because the null is that the difference is less than 0. So anything less than 0, we're not rejecting. Anything more than 0, we're gonna get suspicious, and we're gonna have a rejection region in our most suspicious 5%, or 1%, or whatever it is.
Okay.
What's the significance level here?
5.
5%, yeah. So our most suspicious 5% is gonna be in that upper camp.
But you're right.
So that means you're not gonna have to do that other step that we did, the -1 then times 2.
We're not gonna, yeah, we won't have to double the area under the curve to get the p-value. We'll just get the area under the curve. Yeah. All right, should we do this? Yeah, all right. So in this case, we're testing canola crop productivity with some sort of new pesticide. So, you know, maybe there's some pesticide that you're selling, or maybe some pesticide that the Canadian government is saying we should promote to help farmers. And it looks like this pesticide may be earning more revenue. In fact, in a sample of this many farms using the new mix, the revenue per acre was $180.90. And the revenue, or this is in thousands, did someone say that? No, anyway, but, well, maybe there's thousands of acres in each farm. So the revenue of the old mix was only 152, so it looks like we've got some promise there, right? An extra $30 revenue per acre, maybe this new pesticide is really working. But this is a sample, there's only 459 in this sample and 295 in this sample. Maybe if we test all thousands of farms in Canada, maybe this wouldn't hold true. So that's what we want to test and we want to see how conclusive the evidence is that we have a useful pesticide that's making more money. So we were asked in this problem to set a null hypothesis proving, can we reject this null hypothesis that the mean, the average income for the new mix is less than the average income for the old mix? Everyone's with me there, right? So if we set that up as our null hypothesis, that would mean the mean in the new mix minus the mean in the old mix is going to be some number less than 0. So that's a fancy way of saying that the new mix is less than the old mix, right? So it's saying the null hypothesis is the old mix will generate more revenue. That's what this is saying. Null hypothesis, old mix is bigger, so generate more revenue. So when we subtract new from old, we get a negative number. So why would we set up the null hypothesis that way? The null hypothesis is that the old mix generates more revenue. But we already have some sample evidence that the new mix is actually generating more revenue. So why are we going to set up the test for the null to be that the old mix is better?
Well, that's the standard.
Okay, I could go with that. That's the standard. That the old mix is better.
Because we have more information on it, because we've been using that, and then so we're trying to prove the new one to see if it
Yeah.
would overtake the.
Yeah, I'd agree with both things you said. Tay said that the standard is that the old mix is better, so we're just going to assume that the old mix is fine. We're not going to invest in a whole new product unless we have overwhelming evidence that it really works. And in fact, we may even hope that we have overwhelming evidence. So if we invest in this new pesticide and start using it, we can say we have conclusive, statistically significant evidence that the new mix is better. So we have positioned the null and alternative hypothesis to prove overwhelmingly something we think is true, and would probably be good for us if we